Thanks, everyone. So I'm going to talk today about a solution that we've developed at Snowflake around the problem of mobility pattern analysis. So we've heard a lot about climate change, we've heard about deforestation, and certainly transportation and reducing our reliance on fossil fuels, reducing transportation costs, reducing cars on the road has a direct benefit to society. There's a really large article in the New York Times Magazine this week around how actually it takes longer these days to go from Columbia University to LaGuardia, right? Because of traffic. We've sort of made our lives worse, right? And so the solution I'll talk about today is looking at how we can actually collaborate and we can use the power, again, of the data cloud to be able to more efficiently get goods to our end consumers and do that in a way that protects privacy and ultimately benefits both our retailers and our consumers. So there's a lot of challenges for logistics, and we saw this really explode in terms of COVID, right? Everybody is ordering everything. We all want it now. I like to think of the example of, I have a dog, and I buy dog food for my dog from my local pet store, and they actually will deliver to my house, which was amazing during COVID, right? I didn't have to go to the store. They could bring that directly to my house. But when I think about, the trucks and the logistics for that local, mom and pop brick and mortar pet store to be able to actually get dog food to my house, there's a lot of challenges there, and we can maybe do that in a better way. So today I'm going to talk about a solution that we developed using something that we call a spatial data clean room. So a clean room is an interesting concept. We maybe all think about, we know, a clean room in manufacturing. But in terms of data, a clean room is a way where you can actually combine data. Two parties can combine their data in a way that protects privacy, but still lets them gain the insights. So the way I like to think about it is, say I'm that pet food store, right? I've got my list of customers, I've got my list of deliveries that I need to make tomorrow. I'm gonna put them on a truck, I'm gonna decide the route. Wouldn't it be great if I could partner up with the local, say, pharmacy and be able to combine our deliveries, right? Because maybe on the same street where I'm gonna get dog food, my neighbor is gonna get something from the pharmacy. They don't want to share their orders and their customers directly, right? That's their own protected information. There's often regulations, right, around sharing PII. But wouldn't it be great if they could get insights? And so you can already do this in Snowflake today because Snowflake is a multi-tenant environment using our row access policies and some other protections such as secure views. You can actually do that, what I would call a double-blind join, where two parties can understand the intersection between their customers without revealing any PII, which is pretty amazing. We have a lot of customers doing that today in the media and advertising space. But if we think about spatial data, I'm not just interested in that intersection of customers, right? It's not just that I want to see, did I also order something from the pharmacy today? But did someone on my street or someone in my immediate neighborhood? And so that's where we get to the idea of this spatial blind join. So if I have locations for customers, right, usually addresses, from two different parties, I can use those row access policies to actually aggregate and group to understand being able to make that spatial join, where I'm essentially anonymizing. None of the information is ever shared, right? It's very easy if we think about, we have a list of points, right? We can aggregate them. We can do clustering. We can do k-means, right? We can get geographic clusters. But think about the ability to do that between two or even more parties without ever having, a single table, right, that has all those addresses. I'm never revealing and sharing that PII. So that's some of the beauty of this here and how we've done that. So if we go back to our example around, Austin, Texas, where I live, we can think about how we can combine, again, across those retailers, we can combine all of the delivery points, we can create those spatial clusters, and then using Carto's vehicle route optimization service, we can then streamline our deliveries. And if I think back to my example that I gave, with my pet store and the pharmacy, right? Each of those would be sending out their own individual truck, right, to do those and manage those deliveries. Whereas when they're able to combine those, they may be able to do the, have one less truck off the road, be more efficient in terms of their deliveries. So a lot of exciting capabilities here in terms of retail, but a lot of other capabilities, right, with that spatial clean room. You can think of any time you have two parties that could really benefit from getting insights by being able to combine their customers, but there's a reason why they can't share them directly. This has a great possibility. And so the last thing I want to announce, Javier already talked about it this morning, but we're very excited to announce next week we'll go live with our public preview for our native H3 functions in Snowflake. Again, we have over 20 functions that will be available and quite a significant performance increase. So encourage you, if you haven't already been playing around with your geospatial data in Snowflake, encourage you to spin up a trial account and take a look at our H3 functions. And with that, I'll leave you today. We have a booth here, and Venkatesh Sakar, who's one of our engineers who developed the spatial clean room and the route optimization, is here today, and we'd love to see you at the booth. So thank you.